Welcome to the presentation or webinar of Hitachi High-Tech Analytical Science. I am Miro Sedler and I'm XRF Manager for EMEA. And my colleague is Anna Wegner, Applications Team Leader in Germany, also for EMEA. So today we will present one of the products we make. It's a handheld XRF product, XMET 8000 model. So we will split it into the section of the presentation for you to understand what the product is. And then we'll move to the live demonstration, which my colleague will do. And we allocate some time for your questions and discussions at the end. So, you can also send messages during the presentation on text, and we will try to address it later on. Excellent. So, thank you, and I will start the presentation. Yep. Thank you, Ed. So, as I said at the beginning, we will speak today about the XMET 8000 series. That's the product which could be used in different sectors, different markets, different applications. We will address this later on. First, who we are. Right? Doesn't move. The slide. Up. Sorry. Okay. Long distance to my laptop. So who we are. The Hitachi High-Tech Analytical Science, we provide high technology tools for industrial and research market. We're a globally recognized brand with a reputation for product excellence. We usually cover the world using our distribution network. So for Malta, we work with Tektraco as our distributor. What do we do? We make optical emission systems, X-ray fluorescence systems, laser systems, and also thermal analysis. So our main focus is to metals. So we analyze metals. We have optical emission systems to analyze metals. LIBS, this is lasers-based system. X-ray fluorescence, which is for the handheld system we will talk today. And we have some benchtop systems to analyze the bulk of the metals or the minerals or the liquids, like for fuels, for example, or the coatings. Which customers are our customers? Basically, it's all of them who do the PMI. Now, PMI is positive material identification or quality assurance, quality check. So that's all the industries where we can deliver our systems, our handheld systems, our optical emission systems. Field inspection. I believe that this is part of your job. So to do all of the identification of the alloys you work with in the pipes or valves, to do a correct grading. Of course, it could be metal production. It is recycling or scrap metals in scrap yards, separating different grades. Now we have a very long tradition in making the handheld instruments. Everything started in the Finnish company called Outokumpu already end of 60s. It was the first portable system in the world. Now that company was developing this handheld or smaller portable system, were purchased by Metorex, who continued to develop. Then this company was purchased by Oxford Instruments, and later on, this Oxford Instruments part of the industrial analysis was purchased by Hitachi, and here we are. That's our group. So as you see, it's a very long experience and knowledge with the development of our systems. So using the three techniques, that's the XRF, it's LIPS, it's OES. We can cover practically every task you need in your field, in your work. So full elemental analysis, including carbon, phosphorus, sulfur, low levels in different steels using OES, but also the heavier metals using Handheld XRF. Our system, we committed to do the highest level of confidence for your work. So it's all this quality control, product grading of all kinds of alloys, including the light element alloys. You can also look to trace elements in steels like phosphorus and sulfur. You can look on low chromium analysis. That's in pipes. It's this job which is called flow accelerated corrosion, FAC. I think that you are familiar with this as well. But basically, it's all the inspection of the pipes or welds, and valves or different components you have in your plants. The work with the system can't be easier. It's very simple. You just name the sample and you measure it. You save the report or you export the report. So the system, the XMET, is already calibrated. So you don't need to do anything. You just start working. In some cases, it's good to have a camera on the system, which you can, is an optional thing, and you can allow to work with camera to focus on a small area of the sample, like in the weld, for example. You can also have a small collimator in the unit to focus actually on a small area, and then also you get the image. Then everything, you can get it with the results to your report. So you have your image, you know exactly which part you measured and what are the results, what is the grading. XMET has the large database. I think it's the largest database of all the handheld units in market. So well over 650 alloys only for IC. But there are others. There's a DIN method, the German method. There's a Japanese, and there's a UK. There's other databases which are in the instrument preloaded, or a user could actually load their own customized database. So we cover everything, all kinds of alloys, including copper, cobalt, iron, which is all the steels, low alloy steels, aluminum alloys, everything. So we have 3 models just to cover all the markets or the needs of customers. So very successful is the model called Smart, which is for steels mainly, or the heavier alloys. In the middle, you have Optimum, which you can use also for light elements or light alloys. And Expert is the higher-end unit, which gives you a best accuracy. All the systems have the latest detector technology. It's called SDD, silicon drifted detectors. So there's no compromise in your results, even with the Smart unit. You get always correct characterization, and it's very fast. So this is showing what you can do in with your units. Steel works, Smart is okay. For your aluminium work, you go for Optimum, or you need a trace elements or very accurate analysis of, let's say, phosphorus, sulfur, or magnesium, silicon in your aluminium alloys, or in extreme cases, 99%, and then you look on traces, you need an expert. There's very easy interface with the icons, and obviously it's possible to display a spectrum, but that's something in the background the normal user is not using. So what you see is a result, and we will show it later on during the demonstration. Now, the XMET has been designed in a way that is super robust and very rugged. It's also very properly balanced, so it's easy to hold it. It's light. And so, when you're using the whole day, you don't get tired with holding the unit for long hours. It's a IP54 rated, which means it's superior against dust or any sprinkle of water, So you can work in a very bad environment in the rain, for example. It has this military standard. It's called STD 810, which is a specific test, which was declared by military, but we are using it to document how robust the system is. There's a nice video, we can share it later on with you, showing the robustness when you actually drop the system from 1 meter, and it's done 26 times. And after this, the system has to work. So it's a very super robust, and we also are fully confident that we can cover the range from -10 degrees, but that's not your case, that's somewhere in the north. But we know that the system works properly up to 50 degrees centigrade. Another protection, how you can protect the vital components inside, because obviously inside you have an X-ray tube. There's a detector of our very costly components. So we use a so-called shield. This prevents this, detector replacement and protects the complete nose, not only detector like some competitive instruments. You can still analyze some late elements. And again, there is a very easy way how to replace it. You don't need to use any screwdriver. You just click it and it will open, and you just replace the window if it gets dirty. So no tool is required. There's a video showing how robust it is, measuring very sharp objects, and it doesn't break. Again, we can share it later on. Battery is very, you can use the battery for at least 10 hours, continuous operation. It's not the battery itself, it's the consumption inside. So it's a very smart energy distribution, or the unit has a very small energy consumption. So the battery lasts very long. That's the principle behind. At the end, of course, you want your results to be stored. So everything is in the system, in the unit itself, in database, always, but you can export it using the USB memory stick, which you can just hook up to the system, to the unit, or you can share this result using a Wi-Fi. With your Wi-Fi connection, you can actually share it and put it on your phone. So all you need to do is just to connect your phone and the XMET, and you get the results immediately and displayed, and you can share it to sending by email or any other social media to the computer which is in a lab, for example. This application is called XTOP, but you can download it free of charge from your Apple Store or Google Play Store, and then you just connect it. We will, excuse me, we will show it later on in the demonstrations. My colleague will show you how it works. Additionally to this, there is a PC version of it, which is called Cloud Service. And then you can just share the result for multiple units, to your manager, which is sitting in a lab, and you can see the results and store it and play with this. So that was in short. I believe there are questions, but we will try to answer them later on. And now let's move to the practical demo. So I hand my part to my colleague. Please. I'm giving you the microphone so you can be heard. And I keep quiet now.
You. Thanks, Miro. Okay. Now, könnt ihr das Bild einmal groß machen? Die Präsentation klein und das Bild groß, bitte. Also einfach das Screenshare beenden. Ja. Mhm. Markus, could you switch off your camera?
Yes.
Okay, because then I can see my camera view a little bit bigger. That's easier then.
Yes.
Okay, I hope you can hear me well. Okay. So that's the instrument we are talking about. That's the XMET. You can switch it on by, was switched on already, but let me show you how to switch it on. So now you can see it's switched off. You could switch it on by pushing the button, few seconds, and now it starts ramping up. Das ist jetzt unscharf.
Focus.
Yeah. No, it is. Yeah. Now you can see.
Oh, yeah.
So that's the welcome screen, let's say. And all you have to do now is just confirm. Of course, this thing is producing X-rays, so you have to or we have some safety switches inside which prevent people who are not trained from using the instrument. First step is you have to enter the password. So we make a relatively easy password now, but this can be changed also. And now it's already ready to measure. So here you can see now we have the measurement screen, and very simply you can just position the instrument on the sample, pull the trigger, and now you can see it starts blinking. That's the indication that X-rays are switched on. The measurement time now is 10 seconds. That's, let's say, the standard analysis time for PMI. And what I've measured now is just a steel tool steel sample. So you can see, probably I will show a bit closer. That worked better previously. Mm. Okay. Yeah, I know. Okay, so let me do it differently. I can also share the screen of the instrument with my PC. I think that's probably better. Give me just a minute. So it is also possible to operate the instrument when it's connected to your PC. Of course, on daily operation, you don't need this. But since the quality of the video image is not very well, I would just mirror the screen for you so that you can see it a bit better. Just switching to English language. Hey. Okay, sorry for the interruption. I will now take my sample again, and can you so now you can see I'm running a sample again. Just position the instrument on the sample, pull the trigger, and then measurement starts. So you can see in this case, the sample I'm running, that's a stainless steel sample, stainless steel 304. That's the grade name of it. So it's a typical stainless steel sample, as you can see. So what you can also see here, can you see my mouse? Yes. You can see the concentrations. In this case, they are sorted like with decreasing concentration, so iron first. And also we indicate the limits for the grades over here. So for example, you see chromium in SS304 is supposed to be between 18 and 20%, and nickel between 8 and 10. And you can see the other elements here as well. So that's yeah, as I said, simple operation. It's a predefined method. So when we ship the unit, it's shipped like this. This method is already on. You just connect, you switch it on, and you can run a sample. So it's really very simple. As Miro said already before, you can. What's my handy? It is also possible to connect the instrument to the Xtopy app. So it's looking like this. As Miro said, you can download it for free. And what you can do, you can not only see the results and too bright. Ja, spiegelt deswegen. Yeah, it's too shiny, I guess. Hmm?
Yeah.
Yeah, now you can see it.
Mm-hmm. Yeah.
You could also take an image of the sample and save the image together with the result. Use photo, and then you can just send it as a message to Miro, for example. So very easy. Also, you can switch between the results by just swiping on the touch. You can see the history, and also you can see the history here. So you can see any samples, and you can also report also historic results. If you click on generate report, you can select which ones you want to create a report of, and then just you can send it to USB memory, to printer, or to a network share. And if you use the Xtopy cloud server, it's also automatically saved into the cloud server, and you can call it from anywhere, from every PC. The only condition is, of course, the instrument has to be connected to a Wi-Fi. Maybe also interesting for you if you use this type of functionality, there's also GPS data saved with the results. So you can even see where the analysis was done. Okay. Of course, there's not only an alloy method on it. Yeah, you can select the method from here. There are really a lot of instruments available for this instrument. So we have alloy, of course, that's the most commonly used method, but we also have the option to analyze regulated goods. That's used for the RHS analysis, for example, in plastics, but also in soda. As you can see, we have car catalysts. We also have some coatings on copper. Something which might also be interesting for you is mercury on steel. That would also be a method. This is mainly used when the oil tanks are refurbished, because the mercury is building an alloy with the steel, and so the mercury is sticking on the surface of the tank. And the people who are disassembling it, they may get intoxicated, and that's why it's necessary to analyze the mercury on the walls of the tanks. And also several other coating thickness applications are available, so that's also possible. Okay, so you have seen the instrument can be connected to a PC if you want to share the application or something. The application can also be downloaded. It's coming with the machine, basically. Another option to analyze samples, if you have very small, tiny samples, we have this benchtop stand available. You can just connect the instrument to this, and you can, let's take the other sample now. So that's really meant for normally very tiny samples, very small ones. You put the sample, you close the lid so it's radiation protected, and then you can pull the trigger to analyze the sample. One more thing, of course, you can adjust the measurement time. I will keep it to a short one, like 10 seconds for the demonstration. But as you have seen, it's very well possible to analyze the sample for PMI within 10 seconds only. Actually, some people on scrapyards, they are even using less, so maybe 5 seconds or 4, because they want to be as quick as possible. Of course, you can also set a sample name. We say sample number 1, for example, and this will be saved also in the database. If I now start the sample, you can see sample name over here. Grade is shown from here, and here you can find the results. So that's now actually a certified reference material, and I also can share the certificate. Sorry. Just a minute. I need to switch my screen. Yeah, I think you should now be able to see my entire screen. So that's the result. That's a famous BAS standard. You probably know this one. And that these are the numbers of the certificate. So you see molybdenum should be supposed to be 9.41, and it's coming with 9.47. So it's really very well analyzed with this instrument within only 10 seconds. Cobalt is also, it's quite a challenging element because it's just very close to the iron, and iron and steel is of course always very high concentrations, but still also the cobalt can be analyzed very well. So the certified reference value is 7.95 and the analyzed value is 7.85. So it's reading very well. Okay. So that was mainly the part of the software. I would like to show you, of course, the language is selectable. There are different languages available. Analysis time we have gone through. Here you can select the method, and I've shown you how to create a report. Just briefly would like to go through the accessories. Therefore, I will stop sharing my screen. So we have a bunch of accessories also available for the XMET. So we have the small benchtop stand, which is every accessories is fitting into the case, except the large benchtop stand, of course. So you have a small benchtop stand with which you can also analyze smaller samples. You can position it like this and put on the lid for X-ray safety. And then we have a so-called backscatter plate, which is used for very thin samples or light matrices like plastics or aluminum sample. You can put the sample on it and just measure it like this. And then we do have the backscatter shield available, which you can use if you, for example, are analyzing like tanks or sheet metal or something like this to protect you from the backscatter of the sample. Instead of the case, we also have a backpack available. So that would be an option if you're really working in the field. How much time?
Yeah, we almost finished at 2 minutes, maybe. Yeah.
Okay. I would just like to zoom in again. Let me see if it works. Jetzt muss ich das finden, ne? Okay, just to show you, that's the nose of the analyzer. Yeah, so what you can see here, that's the film, protection film, that can be easily changed by pushing the button here easily. Yeah, I know. Couldn't. So we have these frames. So if there is some dust or something like this on it, you can easily remove it and put a new one on it. So that's very simple. And here we have the proximity sensor, and the proximity sensor is checking if there is a sample in front of the instrument. And if there is no sample, it's not allowed to pull the trigger. That's also a safety feature of the instrument. Additionally, you could cover the proximity sensor, but if there is nothing else in front of the tube and the detector, it will also switch off if the detector doesn't get any feedback from the sample. Yeah, that's basically it. It's the XMET. in short. If you have any questions, just let me know. For the questions,
Yep.
maybe come back. And
Yeah. So now it's a room for any questions. We can address anything. So let us know. Did we miss anything in the presentation? Did you like it?
Yes, it was very informative. Thank you.
Miro, I have a question also for the benefit of the participants. Apart from using the XMET for finding out elements in metals, can you go through other uses of the XMET?
Well, yeah, I mean, we can certainly confirm that the instrument can be used for, let's say, minerals, so analysis of different elements in minerals or ores. But that would need to be loaded with different methods or calibrations, if you wish. Also, you can measure the in plastics or metals the ROHS elements. This is something we have on our unit here as well. So this would be for compliance, for regulation. Then what I didn't mention, I think this is basically it. All of this. So, and the coatings, you can measure coatings if there is any, something coated. So, not sure if there's a room really to display all, the full presentation for the mining. So, but however, is there any concrete question or interest to what the customer needs to do, then please raise the question and try to answer it.
A couple of questions from my side, please, Rene Kassar. So regarding the minimum thickness that can be measured through the XRF, what would that typically be?
Well, the minimum thickness, that's not so easy to determine because it depends on a lot of parameters. But the calibration range for the XMET is approximately 1 to 20 or 1 to 30 micrometers.
Okay. So
there's no answer. You cannot answer this in general. It depends on the element. It depends on the base material, and so on and so forth.
But
for example, if I can, for example, passivation layers with zirconium or chromium or something, or titanium, typically are just a few below 1 micrometer, and this can be determined as well. Does that answer your question?
Yes. So sometimes we're asked to check the galvanizing layer of steel, and that is typically determined, even with the lower models. Okay. And regarding calibration periods, would that be recommended to send the instrument for calibration every so often?
I think that very much depends on the rules which your company has. Usually the customers send it once per year. So normally the analyzer is self-correcting, so it should work. But for the to comply, let's say, with the local regulations or the company regulations, you can get the certified result of, let's say, recalibration. And this is something we do in our office in Germany.
Okay. But I believe that there will be the test sample now with the instrument, and if there is a deviation, then within that year, an action would need to be taken.
Yes, exactly. Every instrument is sent with the check samples, which is a certified reference material with the certificate. So you can, operator can do it every day and see if it's still within the limits. It should be, unless there is some, defect. And as I said, the normal, there's a self-correction during the day. Unless there's a defect, it should work. But you can check it out with the sample, and that you get the confidence that the instrument is working always.
Okay, thank you very much. And maybe one last question from my side. Regarding the registration of the instrument, I know. I think it depends on the local regulations. But is there any EU-wide typical regulation on the registration of new XRFs?
That's typically can be answered by the local supplier.
Okay.
They know.
I mean, we issue the document which is
Yeah.
showing the how radiation safety
Yeah.
documentation, which shows that the instrument is safe. There are so-called interlocks. I think my colleagues just showed it to you what it means. But so it means that you can't just irradiate somebody, and so the message is it is perfectly safe, and the authorities or the bodies in Europe, for example, they just approve it, but as a type approval, give it type approval. Not sure how is it in Libya, but I would guess that this is not more strict than in the European Union, so it should also comply.
Okay. Thank you very much.
Thank you for your questions.
Short question from my side. That film that you showed in front of the nozzle at the end of the presentation, yes, does it have a specific lifetime? Does it need to be replaced?
You mean the film?
That rectangular plastic. I don't know exactly what. Not that one. It's in your hand. That
You
one,
mean
yes.
the film in front of the?
Yes. Yes.
Yeah.
Does it need?
No. It's actually just replaced when it's dusty.
Okay.
Yeah.
Yeah, there's a set of 5 pieces which you get with the instrument already. So unless you really make it dirty, measuring on some very dirty surfaces, you don't need to exchange. And you can buy a stock of it. We say it's not expensive.
And also, you showed us that it can generate certificates, and you showed on your laptop. The template for that certificate, is it fixed or can it be edited? For example, if there's an update to the standard that was reference certificate, can that be updated from our side?
Not sure if I understood the question.
You showed us that certificate that the XRF can generate. Correct.
No, it was there was not a certificate that XRF generates. It's
Yes.
supplied with
So,
the sample.
in that report that it generated, there was a reference to the standard. So in case there is an update to the standard, can that template be updated or automated?
I don't understand.
The text.
The IP 45.
I think what Julian is saying is when you issue the report, can the report be edited? Am I right, Julian?
Yes. Yeah.
Can we
No.
edit the
Not the
report?
data. For example, the reference to the standard. I don't think you can understand.
No.
Not sure. No. I mean, you get a sample, like stainless steel sample with the certificate. That's fixed. If
I think he is referring to the report that the software generates.
Yeah, when you measure the sample, you get the result. Right, so you can compare with your certificate if it's still within the limits. Obviously,
Okay,
you cannot.
Before you print
edit.
it,
Yes.
Before you print it, can you add some details on the report?
Oh yes, you can add the details.
Okay.
Sorry, misunderstanding. So you can. But you cannot edit the results.
Not the results.
But you can add the details, like description. Instead of just a name, you can put a lot of description.
Okay.
Comments, anything. So this is done in a You can define a template editor where you can actually put a default name of your company and description, headers, footers, whatever.
Okay.
And then additionally to it, you can put a comments when you actually measure the sample. So it's quite flexible. Is that what you meant?
Yes. Thank you.
All right. Thank you. All right.
Are there any further questions? Okay, it seems that there are no more questions. I'd like to thank you for attending. As mentioned, we will have more similar webinars. We will send you invitations for the next upcoming ones. Thank you again. And if you have any questions in the future, of course, you can always send us an email and we'll be happy to help.
Okay.
All right.
Thank you very much.
Thank you for coming and joining this webinar. I hope you enjoy it, and I hope we will be all in touch through our distributed tech tracker. Come back to us when you have any other open questions, and have a good day.
Thank
Good
you.
day. Thank you. Good day.
Thank you.
Thank you.
Thank you.
Bye.
Bye-bye. It's just us, right?
Yes.
Yes. It's no customer anymore.